Hello students, in this video we would learn a few properties of triangles which will be very useful in the topics coming in the next videos. So first of all, what is a triangle? A triangle is a closed, flat or two-dimensional figure bounded by three line segments. And here you can see triangle ABC, and a triangle has 6 elements, that is 3 sides and 3 angles. Now in the given triangle we can observe that it contains 3 sides, that is AB, that I am again drawing over, I am overlapping it, AB. After that this is side BC and this is AC, and 3 angles, angle CAB. So you can observe angle CAB. So this angle is one of the angles. Second is angle ABC, ABC. So we can mark ABC like this, and angle BCA, this one. So it is obvious that a triangle contains 6 elements, and we can describe a triangle under these 6 elements. Now we can observe that I am having 2 plane figures, flat figures, 2-dimensional figures. One is triangle and other is a quadrilateral. Now we can observe this is a quadrilateral. If I apply a force on this quadrilateral, then we can observe that what happens. We can observe that on applying force it gets deshaped. It remains quadrilateral but its shape gets changed. But if the same amount of force is applied on this triangle, then we observe that there is no change in its shape. So we can just conclude that a triangle is the strongest figure among 2D figures. Now in a triangle, if I talk about the area of the triangle, then we can observe the area of a triangle is, all of you know it very well, area of triangle is half into base into altitude. Altitude means height. Now suppose we are having this triangle ABC. Now this triangle has 3 sides, and we can consider any side as its base. And suppose if BC is base, then the corresponding altitude is the altitude which is drawn on BC from A. And how do we draw it? Please see it, very important. I am keeping a scale along the side BC and it is a set square. Now if I keep a set square like this, so that it is coinciding with this side, and we bring it like this. Now this is along A, and if I draw a line like this, then we get a perpendicular, and this is perpendicular, say it is P. Now the area of the triangle, so let I write area of triangle ABC as half. Now base is BC, so I can write BC, and the corresponding altitude is AP. So I would like to repeat, area of triangle is half into base and corresponding altitude, not only altitude only, corresponding means the altitude which corresponds the side BC. Suppose if I consider AC as the base, in that case, if I consider it as a base, in that case the perpendicular is drawn like this. Again I keep the scale coinciding this side AC, and again I keep this set square like this by coinciding it along this scale. So this is the perpendicular on side AC. So again, if I want to write the area of the triangle, then I can again write half into. Now base I have considered AC and perpendicular is BQ. And in the same way, if I consider AB as the base, in that case the perpendicular would be this one. So suppose this is R and it is perpendicular from C to side AB. Again, the area of the triangle can be written as area of triangle ABC. Here also area of triangle ABC can be written as half. Now in this case, base is AB and the corresponding altitude is CR. So in this way, we can see that a triangle can have base. Any one of these can be considered as base BC, AB or AC, but whenever we have to take altitude, the corresponding altitude is considered. Now we can observe from here that this point, the point of concurrence of these three altitudes, is called ortho center. Ortho means perpendicular. So the point where all the three perpendiculars of a triangle meet is called ortho center of the triangle. Now if I talk about perpendiculars, now in this triangle, as it is an acute angle triangle, as all of you know, acute angled triangle. Now if I consider another triangle, that is obtuse angle triangle, so we can see its altitude, it is not necessary that lies within the triangle. It may be possible that the altitude lies outside of the triangle, in the exterior of the triangle. Suppose this is a triangle PQR, you can clearly observe here that angle PQR is an obtuse angle. So this triangle is an obtuse angled triangle. If I draw a perpendicular from P to QR, in that case we can observe that the altitude lies outside the triangle. So I am drawing it, and in order to show the altitude, I have to reproduce RQ, and on reproducing RQ we get this altitude. Suppose it is PA. Now if I draw a perpendicular from Q to base PR on the side PR, so again I coincide this scale with PR and draw a perpendicular from Q to this base PR. So here is the perpendicular. In the same way, if a perpendicular is drawn from R to PR, so we can observe that here in this case again the perpendicular is lying in the exterior of the triangle. So it is obvious it lies in the exterior of the triangle. So it must be clear that the altitude may lie within the triangle or it may lie in the exterior of the triangle, and it is dependent on the case whether the triangle is acute angle triangle or obtuse angled triangle. In case of a right triangle, we can observe that the two perpendiculars lie along two sides. Now ABC is a right angle triangle with right angle at point B, at the vertex B. AB is perpendicular to BC and CB is perpendicular to AB. So the two perpendiculars lie along the sides of the triangle, and the side opposite to the right angle is called hypotenuse. Now BM is perpendicular to AC. Now here we can also observe that the three perpendiculars, that is AB, CB and BM, all meet at the same point, that is B. Now here B is also the ortho center of the triangle. Now another very important concept which is related to triangles is, that is, median of the triangle, and it will be used in the coming lessons and coming topics. So a median of a triangle is a line segment joining a vertex to the midpoint of the opposite side. Now here I am having a triangle PQR. In this triangle we are having three vertices P, Q and R. I have already marked the midpoints of the sides. So if I consider P as one vertex and the side opposite to P is QR, and if I join P to the midpoint of the opposite side, then I get this as one of the medians. Suppose it is A. So PA is one of the medians of this triangle, and as a triangle has three vertices and three sides, so therefore obviously triangle has three medians. Again, if I draw a median through Q, then Q is a vertex and the opposite side is PR, and if I join the midpoint of PR to Q, then I obtain the second median, say it is QB, and the third median, if I talk about to R and to the midpoint of the opposite side, I get C. So here we also observe that all the three medians of the triangle are concurrent. Concurrent means the lines which pass through the same point, more than two lines. Here these are three lines or line segments, PA, QB and RC. These are three line segments and these pass through the same point, so we call them concurrent line segments, and the point of their concurrence is called centroid of the triangle. Centroid of the triangle, and it is a very important point within the triangle as it is the center of gravity of the triangle. If I try to rotate this triangle along this point G, then it can be done with great ease. If this point is exact, in that case it can be balanced easily, and it can be balanced easily as we can observe. And if I try to rotate it with a little practice, then I can do it. I have not done a great practice, but even then I am trying to rotate it. Now we can see that it can be rotated easily. So that's all for this video. Thank you, thanks a lot, and try to find out the importance of centroid and the orthocenter of a triangle, how these 2 points are important and how these are used in our daily life. Please try to find out that. Let us see or let us meet in the next video. Thank you very much.